H2K Infosys provides world-class online IT training, staffing, and software testing solutions to customers worldwide. H2K Infosys supports 100% job-oriented training, hands-on project work, cloud test lab, resume preparation and review, mock interviews, robust syllabus. One-time pay, lifetime access to live classes and videos. H2K Infosys has won the trust of thousands of students worldwide. For free demo class, visit h2kinfosys.com.
Yes, obviously, right? So I'm an object, I'm physically available. My laptop is an object, my mouse is an object, my chair, my table, whatever I see around me, which I can feel physically, touch and feel, is an object for me. Okay, that is where the object-oriented programming mainly involves. But the first concept in this is class and object. What is, okay, object, I understand. What is class? Object is a physical existence, classical is a logical classification. For example, who am I? I'm an object, but I belong to a class called human being. My laptop belongs to a class called laptop. My mouse belongs to a class called mouse. My table belongs to a class called furniture, for example. Right? So this is a class. Class is a classification. So can I call myself as a laptop? No. Can I call my laptop as a human? No. Can I call dog as tiger or tiger as fox? No. Why? Though they are objects, they belong to a certain class. What is that class? A class contains, okay, behavior and attributes, or we also call it as actually there is what is that? Data and behavior. Okay, behavior and attributes, which is data. Okay, so that is how it is. For example, I belongs to a class human being. You also belongs to a class human being. Everyone in this world, all human belongs to a class human being. Why? Because it has certain behavior and physical attributes. What it is? Every human normally 2 legs, 2 hands, head, all the physical attire whatever needed, that is it. What is the behavior? I sleep, I eat, I run, I walk, okay, I talk, I sing, I play. These are all the behaviors. And is it not common for all the human beings? Yes. So your class basically defines you who you are, and your object is actually the physical appearance for you. So class here is a logical entity. It is not physically available. If I take tiger, what are the properties? It can roar. It has 4 legs. It has all the hair, whatever you call. So that is the behavior of that. Based on that only we can say tiger. If it is barking, because tiger is barking, we can call it as a dog. No, tiger never bark. It roars only. Right? So that way, class is a logical entity. How do we define objects by its class is called a class. Okay, we will discuss in detail later chapters also. I'm just giving a basic introduction. Now we are objects. Now, for example, let's say my table also I'm saying object. Why? It has certain behavior and properties. What it is the behavior? I can move wherever I want because it has 4 wheels. Properties, it has 4 legs, okay, and then it has a top. You have a wood where you can easily keep things. Simple chair, same thing. Okay, so everything falls under a class. Class is a logical entity. Instance of the class is called object, which is a physical entity. Okay, instance of the class is called object, which is a physical entity. So that is where all object oriented programming revolves, right? Okay, these two are the basic things. Don't worry, we will discuss in detail when we go into the deeper into the program. Fine. Now let's see. One is encapsulation. For example, encapsulation, our object itself is an encapsulation. Reason, I keep whatever I want only with me. I don't share it. I share only whatever I wanted to with someone. right? For example, my wardrobe, I use myself. I have a bike, if my friend need, I will give, or I have a car, if my relatives need, I will give, right? So encapsulation is nothing but securing yourself with all your things. Okay, so we will discuss in detail later. Now inheritance. Inheritance easily talks about blood relations, for example. Okay, what is inheritance means? A class can inherit another class properties and behavior. Okay, simple. For example, now I'm staying with my father and mother in a house. Actually, it doesn't belongs to me because my father bought it, for example, or built it. Now I'm staying with them. Okay, what does that mean? Why only I'm staying? Why can't a stranger come and stay? Because we have a relationship, parent child relationship. That means properties of another object I can even enjoy. So this house belongs to my father and mother, but I am staying here being I'm a child of them. So that means what? We have inheritance. So a class or an object can share with something with other. So that is what is inheritance. All these are real world examples only. I did not deviate from real world so far, if you see. Okay. Anyhow, we will see that. That means what? A class can share its properties and behavior to other class. That is what is inheritance. And then polymorphism. The name itself says, tell me what do you mean by poly? Many. Morphism means forms, many forms. Okay, what is that is? If you see our body itself is polymorphic body. Okay, I have hand. Can I use hand only to eat? No, we use it for different purposes, right? That is called polymorphism. Okay, and similarly, for example, let us take ticket. I hold a bus ticket, for example. Can I board a train or a flight? No. I have a flight ticket. Can I board a train? No. Why it is? Though the name is ticket, but the purpose is different. That means a ticket has many forms here. If you have a bus ticket, you can only board bus. If you have a train ticket, you can only board train. If you have a flight ticket, you can only board flight. So though we call it as ticket, but it doesn't mean that it is actually a common. So similarly, polymorphism is nothing but one can be doing multiple purposes. Okay, anyhow, that we will see. Abstraction and interfaces. What these are actually, abstraction and interface falls under same category, actually speaking. What these are is, we don't have few things in our things, but somebody else can develop on behalf of us. For example, let's say I'm purchasing something on a e-commerce site. Okay, I'm purchasing something. Now I want to pay. For example, I added all the items to my cart and I went to checkout and I want to pay. Now what will happen? I need to give my credit card information or debit card information or whatever it is, the payment way I have, PayPal, whatever it is. Now tell me, are they banks? For example, take Amazon itself. Is Amazon a bank? No, right? It is just a e-commerce website. But then how do I feed my data there? How do they get the money? Simple. They have an interface between bank and us called payment gateways. Example. Payment gateways are the real example of our interfaces. Amazon is not a bank. I am a bank customer who holds some credit card or debit card or whatever be the way of method of paying. But Amazon is an ad bank. But when I given them the details, how come Amazon get the money? Actually, what happens is your payment gateways are interfaces between you and your e-commerce company here. What those interfaces does is they will implement the actual bank transaction process. These you will be just informed saying that you are debited and that particular e-commerce site will be informed that you are credited, whatever be the information you want. And all the transactions really actually done by your bank. It's not anybody, because they are the one who hold all your money there, not your e-commerce websites. So that is one simple example in real time. Okay, that's it. So these kind of scenarios we apply in the programming itself. Okay, this is why it is object oriented programming. So don't worry, we will discuss in detail when it comes. Now the very good next feature of our Java programming language is
the abstraction, Srinivas?
sorry,
What is the abstraction?
abstraction is also similar like interface only. Okay, abstraction is also
Okay.
same. So we actually the name is different, only difference is here class does, here interface does. Okay, don't worry, these actually both are under same umbrella. Okay, we will discuss that. Okay, now platform independent, this is one of the feature Java made very famous. What it is normally if you want to create a C program in Windows operating system, you could create a C program in Windows operating system. The same program you cannot run on it, Unix or Linux or any other operating system. Why it is whenever you're creating a C programming using any of the operating system, that program is created for that operating system only. It cannot be used by another operating system like Unix or Linux. And many of the programming languages are like that. For example, if you see all older programming languages, they are like that. Okay, including C++. Even it is object-oriented programming language, remember. Okay. However, Java is not like that. You create a program in Java, you can run on any operating system in Java. Okay. How it is? Java is platform independent. Okay. But there is a caveat here. What it is it's not pure platform independent. That means I blindly take that program to Unix. If I run it, it may not work. There is a rule. I will explain with a simple diagram. For example, let me explain you what happens when I have a C or C++ program. Let's say this is a C program. Okay. Now, when this has to be run, normally what happens is based on the operating system we are, for example, on Windows, right? What your program basically contains is all English text only. But does that English text is understandable by your computer? No, computer cannot understand your English like text, guys. Remember, whenever we created program here, your computer don't understand this. This is an English text. How does computer understand? Your actual computer understands only machine language. Machine language always in zeros and ones. Okay. Now what happens whenever you compile, right? Your compilation will actually convert your program into the this compilation process convert your English like program into the program which machine can understand. Then only our programs will run, remember that. Okay, which machine can understand. That is how our programs run usually. Okay, now what happens is in the traditional programming languages, because you are using Windows operating system for C, so whenever it is compiling, right, it convert into this program where it can understandable only by Windows operating system. That is why this program, whenever you are created under Windows, you cannot run this under Linux or Unix. Program you may copy there and you can recompile there, it may work only as a text, but the compiled program or the software whatever it is created, you cannot blindly take it to that machine and ask it to run. Okay, reason being it is developed under Windows operating system with C. So it can run only there. However, Java is not like that. What Java does is, see this here, any programming language, any operating system, Java program, whenever it is compiled, what happens is it creates a intermediary file called class file. Remember, it's not the mission file, mission language file, it is a class file. What we call is a class file. Okay. Now this class file can be executed by any operating system, but provided that machine has JVM, Java Virtual Machine or Java Runtime Environment, which we discussed. So for example, this is Windows. Windows with JVM, no problem. Linux with JVM, no problem. Windows or Unix with JVM, no problem. So it is. So that way I'm telling it is not pure, it won't convert in the actually pure format, in the sense just run that program in operating system, not like that. It won't really convert into very pure. Okay, for example, let's say Linux, like this. So this class file can be run by your JVM or Java virtual machine, where it can be run in the same way for any operating system. So now you may ask me, okay, is JVM is different for different operating systems? Yes. If you remember, we were talking about the installation. You could see there is installation for Windows, installation for Linux, installation for Mac, installation for Unix, right? Based on that you need to take. Okay, so this JVM is different for different operating system, but your Java program and what is the intermediate file to create class file is not different. It is same class file which can be run on same JVM for Windows, okay, and then JVM for Linux or Unix, JVM for Linux. This is the difference. This is why Java is platform independent. That means irrespective of your operating system, you can run your Java program. That is the main benefit what it is. Actually, if you see the history how Java was born, right? C++ was having the same disadvantage. They want to invent a programming language which can be used across multiple operating systems. That was the intention, and especially for home appliances. James Gosling and all, they started in the mind that they want to create a programming language for home appliances like fridge, TV, these kind. Reason being, earlier everything was electrical only there. There was no computerized way to do that job. And during that process, they invented Java, which is platform independent. That means whenever it can run on any operating system, it can run anything. So if your home appliances use Unix or DOS or any other operating system, you can do, right? So that is the intention. That is how it was born even that way. If you see, it was born out of the different way for doing. But if you see now, Java can be used in web applications. Java can be used in to create a Windows application. Java can be used to create mobile applications, right? That is how it is. That is why it is platform independent. Okay, so that is the main feature of Java, which is platform independent. Then secure. Java is much secure than any operating system or any programming languages available in the many of the programming languages available in the market. Reason being, as already told you, whatever be the C++ complexity like pointers and all, where we give access to memory and all, is discontinued by Java. So all those security vulnerables are gone away. That is the reason Java is secure. That is why people say you can't create virus programs in Java easily. You can create virus programs in C, C++ easily, because still they do have concept of pointers and that. But you can't create a virus program via Java easily. Reason being, Java is much secure. Okay, and then it is robust. Robust means which has the strong memory management, where memory will be properly managed so that our system will be actually fresh always and keep the things intact for us. Okay, so That is why it is robust also. It is strong. It has memory management, lack of security vulnerabilities, and also it has garbage, automatic garbage collection, which I said it automatically flush out whatever be the memory we don't require anymore. Okay, you don't need to tell, okay, do it. Then architectural neutral. This is also one of the feature which is different from other programming languages. What it is architectural neutral means depends on, there are normally two types of architectures in our hardware systems. If you see 64-bit, 32-bit, that's what we discussed also in the last session when we were discussing the installation, right? Well, I asked you to see first whether your system is 32-bit or 62-bit, right? So system information, when you go, you will see not this one. We would see here 32 bits or 64 bit. See this here, 64 bit, right? Normally older systems are in 32. Right now I don't think any system is coming up with 32. Older systems are in 32 bit. So what it is it is the you can think it is a hardware configuration only. That means it can process 64 bits at a time. 32 bit it can do 32 bit only, based on, because it is processed 64 bit, right? It is having much more capability with respect to the computations in electronic terms. Okay, with much more capability, speed, everything will be better. Okay, so whenever you take the older programming languages, right, like C, C++, when you run on 32 bit, when you run on 64 bit, the behavior is different. For example, you are storing a value called 10 in a variable. Normally in C, integer occupies 2 bytes. In 32-bit, it occupies 2 bytes, means if you run the same program in 64-bit architecture, it takes 4 bytes. It increase or double it. Okay, that means it is not consistent among the different architectures. But Java is not like that. Irrespective whether you are on 32-bit or 64-bit, Java works same way. So you are taking your Java programs to different operating systems or different architectures, it is same. For example, earlier Unix used to be 32-bit only earlier. Okay, so that if you see, it is, of course, now I don't think anybody using Unix, and now everybody shifted to Linux. Okay, so that way it is 64-bit, but normally. So I'm telling, so this is how it is. So Java doesn't differentiate. It doesn't differentiate your operating system. It doesn't differentiate your architecture. Okay, that's it. And it is portable. Portable means actually in Java, it is very easy to plug in and play of your components. Very easy. You will be learning that whenever we go into Selenium and all, you will understand how we integrate Selenium very easily with Java. Okay, Selenium is also Java collection library only, if you see that way. Okay, so how do we do? So that we will see, and it is very high performance compared to C or C++, which are their predecessors. Java predecessors are C, C++, right? As I told you, Java is successor of C++. Okay, so it is having very high performance. Reason being, it use class a bytecode, Java class file or bytecode, which is way faster when you compare with. Okay, there is also a reason for that. Why it is normally in memory, right? For example, okay, whenever this particular program runs, it always goes by your system memory by default. If your system is having less memory, it will be slow. But Java is not like that. Whenever it is executing, what Java does is, in your main memory of your computer, it creates a separate sandbox, what we call. Okay, that means your memory is preoccupied by JVM or Java, and in this memory only all the Java operations will be performed. Now tell me, is it not much secure than your usual approach here? Right? Obviously much secure, because it won't allow access to anybody else. That's why Java is secure also another way. Okay, so that is how it is. We will see. That is the reason it is high performance also. Reason being, it doesn't use your default memory, it will be created under a sandbox called JVM. So that will be high performance as well. That is another reason as well. And now one more thing is Java is distributed. Distributed programming means networking. Java is very suitable even for distributed programming also, like networking, like internet. For example, we can create even websites easily with Java, right? So it is used for internet. For example, it has certain people might have heard RMIs and EJBs, enterprise Java beans and remote method invocation or JSP. All these part of your distributed only. Multi-threaded as well. What is a thread means? Thread is like a process. Okay, thread is a process. Process means, for example, if I have one program, if I'm running a program, it creates a process for an application, right? So that is called a thread. But Java is multi-threaded. It can run same program in multiple threads or multiple process. Okay, though we don't use it in our regular usage every time, certain stages we use. For example, Selenium grid, we talk about this multi-threading, but we don't require to learn this. So this distributed and multi-threaded, we are not going to learn as part of our course. Okay, because these are advanced concepts, advanced Java, J2E, what they call Java Enterprise Edition, right? So that use, that's fine. And then Java is a very dynamic language. Dynamic in the sense what it is, as I told you, it's automatically clear memory. We no need to bother. So dynamically it takes off memory automatic management. And also you will be learning in the program certain things you can load during the runtime, during the compile time dynamically, during the runtime dynamically. So that is why it is dynamic also. That way it is actually much faster as well. Okay, compare with traditional or older programming languages. That's it. So that is it. So that is about the basics why Java is powerful now we have seen. Okay, so in the next session onwards we will continue with the real programs. Okay, what is a variable in Java, and then we also get into object oriented also. First we learn without object oriented whatever we required for the basics, and once we complete the basics part, then we jump into the object oriented programming. Okay, so that's it for today folks. Any questions? Am I